I supervised one of the labs yesterday, and the lab I was in, we seemed to get loads done. We got quite a bit finished and working, didn't we? And we had a few fun and games, didn't we, trying to get it sorted. But I think most people certainly in the lab I was in, had a few problems, managed to get everything working okay, and got a headless server running, which is quite impressive. Okay, so well done for that one. There's two shorter presentations I got for you today, mainly because the first week's presentation ended up being too long, and the second week ended up being too short. So I've lopped a bit off the end of what I was going to do with you last week and tucked it on the front of this week's presentation. So it's a bit of a mixture. The first thing we're going to do is look at the user accounts and permissions. Because if you come from a Windows world, the idea of permissions and accounts is a bit sort of a vague, nebulous concept. But it's fundamental to the way that Linux works. So we need to be absolutely 100% rock solid on accounts and permissions if we're going to get the rest of the labs done. So it's worth spending some time. So 3 objectives. To be able to understand how Linux controls access to files, because remember that's all it is, it's basically a text-based system. To create and manage user accounts. And finally, to create and manage groups. And the concept of a group in Linux and Unix is fundamental to the way that we work. And if you don't get groups, you won't be able to cope with the 4th task. And probably struggle with the 3rd one. Okay, access control. Basically, we have an access control system to control access to every single file and folder on the system. And when we talk about files, everything on Linux is a file. Your SD card you shove into a Linux computer becomes a file. The hard drive is a file. All the configuration is done through files. Everything is done through files. And we can control all this through a very simple but powerful access control mechanism. And it has some wonderful commands that go with it, like chmod, chgrup, chown, and all these sort of things, because we're lazy. We don't like typing too much. A user. Now, when you think of users on a computer, you think of people sitting in front of a keyboard and working on the computer. In Linux, any system or service that needs to access the computer has a user account. So if you install Apache, the web server, Apache is a user account. It's a user on the system. So you have to make sure that that user has permission to access certain things. If you install FTP, the FTP daemon is a user. You need to make sure that user has permissions. It's so ingrained into it, you can't do much without user permissions. Now, if you are the root user, there's only one root account on the system. It's not like Windows where you can have lots of admin accounts. You may only have one admin account on the system. Therefore, if you have one admin account, you have accountability, don't you? If you have lots of admins, and lots of admins are changing things, you don't know what's going on. But if there's only one admin on the system, you can control who has access to what. And basically, you can change the owner of a file very easily, or a file or a folder. If you want to change a file owner, you use the chown, the change owner command. You specify the username that you need to have access to it, and then you just keep adding files to the end. You can chain as many files as you want in the current directory, and it will simply set the ownership of those files to that user. With ownership becomes control. So every file has an owner and only one owner. Every file has a group and only one group. So mixing those together allows you to control access to the system. If you want to change a whole folder, if you think about it, there might be other folders inside that folder and deeper and deeper and deeper recursively into the folder structure. So we have to have a special flag called R, stands for recursion. So it says change that folder name to that new user and recurse everything inside it, including subfolders and sub-subfolders and everything right down. Otherwise, you will change the folder permission, but all the files inside that folder will still have the original owner. So that little R flag is really, really important. And we talked about flags last week, didn't we? We briefly mentioned the idea of flags. Yeah, little dashes with the short flags, which are single dash and a letter, and there's long flags, which are 2 dashes and a word. And sometimes you've got a choice of both. So we've now changed a folder and a file. Again, changing groups is the same idea. Instead of chown, it's chgrup. Okay, so we just remove any vowels in there. and that changes the group. So the same idea, you can change the group owner of a file and also change the group owner of a folder and subfolders. So you now know how to change those, but I haven't explained exactly why. The idea with groups is you can put lots of users in a group together. You set up these groups and you add users to groups. So your account might be a member of lots of different groups. It might be web editors, it might be a member of developers, it might be a member of students. You can belong to many, many groups, but each file or folder can only have one group associated with it. So you can see how you need to create groups to be able to manage access to different files. If you want two people to access the same file, you've got to create a group for them and assign that group as the group owner of that file, and they will have permissions on that file. Okay, now, this is the really fundamental bit. Once you get your head around this, you kind of can't understand why you do any other way. Basically, we know that every file and folder is owned by an owner, a user, and a group, don't we? So far. Now, within that, there are three possible permissions that owner can have and the group can have. If you think about it, this covers pretty much anything. There's read permission. They can see the file and open it and have a look at it. Write permission, which means they can edit the file and change it. And execute permission, which means they can run scripts and run commands. So they can run the file. So read, write, and execute. And execute, letter X stands for execute. Okay, so RWX, you'll come across this over and over again. If I list my directories and I do an ls, I can have a little L flag, that's an L, not a 1, and that gives me a list view. And there is the contents of my home folder at the moment. Well, that's about 6 months ago, to be honest. That's the contents of my home folder. And look how much information is there. It tells us everything we need to know about every single file and folder. Now I can tell you that there are 2 folders and 3 files there. How do I know? Look right on the left hand side. Actually, you think it's a full stop, wouldn't you? It's not. Folders can have full stops and files don't have to have extensions, so it's good thinking. Look at the first character on each row. Yeah, it's a D. A D for directory. That means it's a folder. That's the only way you have of telling it's a folder. There's no other way of telling. When we do next year, when we do Git, we create folders with a .git extension, and that really confuses people. Basically, the contents of the file is known by the system. The file extension is just for us to remember. That Python file I could just call account_gen with no file extension. And when I try and run it, it will say, oh, it's a Python file. It's a fundamental part of the system. It knows what type of file each file contains. Now, if we look next, can you see there's some R's and W's and X's going on? Those are the file permissions, and we'll talk about those in a minute. Read, write, execute. If you look at the bottom one, the CSV file, how many RWXs have we got there? If we like going cross-eyed. How many RWXs are there? 8. No. 9. Yeah, there's 9 RWXs, and we'll explain what that means in a minute. Next to it, we have how many pointers are there to that file, how many shortcuts, how many times does that file occur. So the top 3, it's got 1, and the bottom 2, it's got 2. Okay? Don't worry for the time being. Next year, we'll talk about symlinks, symbolic links, and you sometimes have 6s and 7s in there. We've got 1, we've got 15, number 15 in that column. We're on the current assignment for the 3rd years. Next column is the owner. And the next column is the group. So as you can see, when I have my account created, I'm given my own group. So if I want someone to access my files, I can add them to my group, like a little gang, okay? If you want them to see your files. Next we have the file size in bytes. And as you can see, the folders are 4K big. All folders are 4K. And I've got a 1 meg file, can you see at the top? So 4K, 1K file at the top, and a 3.2K file next down. Those are in bytes. Then we have the last modified date, okay, time and date, or just date actually, yes, date and time, and then the file name at the end. With very few exceptions, that's everything you need to know about what you see when you start looking at files. Now, this RWX, yeah, this bit at the beginning, which we got a bit confused over. Now, That top example, anyone who has an account on that computer can read, write and execute that file. Okay, I'm going to see if you can figure out how the logic works. The next example down, the file owner can read and write, and everyone else can only read. Can you see how I'm getting this information out of those funny characters? You see what's going on there? Now, this is the secret slide. This is the one that hopefully makes things clear. There's 10 characters. The first character is always either a dash or a D. If it's a dash, it's a file. If it's a D, it's a directory. We don't have folders on Linux, they're directories. Okay, so if you talk about folders, you get a sort of a rule around the ear, and you're told to call them directories. Now, the next 3 characters are the file permissions for the owner of that file. Yeah, the username that appears in that column, that users column. Okay, that makes sense. The next 3 are for the group owner of that file. So in other words, anyone who's a member of the group name that appears in that list view. The third RWX is everybody else. So if that was a permission, it would say the owner has read, write and execute permissions, the group owner has read, write and execute permissions, and everyone else has read, write and execute permissions. And it's sometimes called 777 or 777 permissions. Anyone figure out why it's called 777? I'll put some very small clues along the top edge. Yeah, it's binary. Every 3, imagine that's a binary number, 1s and 0s. If it's a dash, it's a 0. If it's not, it's a 1. 4 is read, 2 is write, and 1 is execute. So 7 means you've got read, write, and execute permissions. A 6 would be read, write with no execute. 5 would be read and execute, which is what the Apache user has. Because you don't want Apache deleting your PHP files, do we? We want to be able to read them and run them. And that's how files and folder permissions work. It looks simple, but when you start trying to figure out how to group people together to give them permissions, it gets a bit more complicated. So here's an example. 754 permission. Okay, that's a classic permission. That's common. 754. And Linux users, 754, yeah, 754, I know what that means. Let's break it down. The first number, 7, is 111, isn't it? Yeah, in binary. So that becomes read, write, and execute. The 5 becomes 101 in binary. So it's read, no write, execute. That's right. And the third one is 4, which is read. So you can see with a simple number, you can express any combination of permissions on the file or folder. So it's really quite powerful tool. So now do you understand, when we looked at that slide, what permissions different users and groups have? Because it's your job in the assignment to make sure that you give just enough permissions to get the job done, but not one bit too much permissions. If you give too many permissions, you're open to being attacked, hacked, and so on. So you need to control those permissions. Don't be tempted to go 777. Yes, you can read, write, and execute, but so can the hacker. So just think about what you're trying to do, and that should help. But user accounts. I had user accounts and permissions, and the trouble is I could think to either way around because the two are so linked together, it's difficult to separate the two out. So this is just arbitrary. I've done permissions first. We're going to create new users. We're going to force a password reset. You know how you have a password reset every 90 days? We can set that up as well. We can force someone to change the password when they first log in. We're going to show how to change passwords, both for the user and as root. And we're going to use something called sudo. And sudo means you will never, ever, ever have to log in as root ever again onto your Raspberry Pi. You will never have root Raspberry. You can change the password to something random, to keep it safe, and never log in as root. It's very simple to create a new user. User add, username. Seriously, that's how you add a user as root. There's one slight problem. We've got to give permission access to the Linux shell. Remember we talked about shells last time, be it Bash and C shell and core and all the rest of them. So we have to, when we set the account up, we have to tell it what shell to use. We have to give people a home folder, don't we? We have to have somewhere for them to save their files. So we need to set that up. And also it's very handy to put a comment when you create an account so you can see why you set the account up in the first place. A little comment at the end. So realistically, that's how you'd create a new account. Now I've tried to colour code a bit to see what's going on. So can you see I've got 3 flags. I've got an S flag for the shell. I've got an M flag for the home folder. Sorry, an M flag to make, a D flag for the directory, the home folder. Yes, the home directory, yeah, is the D flag. The reason I put an M flag in there is M says if it doesn't exist, make it. If you miss that M flag out, it would say directory not found. So you're forcing the system to build a home folder for that user if you put the M for make. And the C is for comment. So you see these are just acronyms, aren't they? These are just abbreviations. So S, M, D and C are the flags you use. Okay, and every command works with flags. So when I say put a flag on that command, I don't mean wave a flag or type the word flag. I mean there's a special parameter you're missing that you need to add. Okay, so to modify a user account, you use user mod, and there's loads of different parameters. The most common is to lock an account. If you pass a capital L to user mod, it disables the account. Simple as. Yeah, it means they can't log in. So I can lock, and U unlocks the account. So very quickly, a system admin can do a little shell script which runs a program and locks a series of accounts. Yep, you can write scripts to do this. Shell scripts, Python's really good. You can actually write Python scripts to run these commands. So you can write Python scripts on your Raspberry Pi to automate a lot of these tasks that we're doing. Okay, and that's what makes Python so good for this. Forcing a password change. Age. Okay. Okay, that makes no sense at all. That's just dealing with a password. -D, 0. So it says that the D is a day flag. How many days are going to elapse before you force them to change their password? And the value is 0, which means now. Right now. So next time they log into the computer, it will say, you need to change your password, enter your old password, enter your new password, enter your new password again, and it changes the password. Look at the bottom one though. I've got 1, 2, 3 flags on there. I'll give you a clue. It's very similar to the way the university system works, except the W, capital W flag is normally 14. What's it doing? That's your warning. 7-day warning to change your password. So from 7 days till the password expires, you'll get warnings when you log in. M90?
90 days.
90 days, yeah. So 90 days. So it's a force of password change every 90 days. And the M0 means you're not going to give them any grace period. So once that password's expired, that's it. You can have a grace period when it says your password is expired, you need to change it now. You know that bit at the end? This one was saying no. You give them 7 days warning, then that's it. Yeah? So you can see, and if you search in the manuals for these commands, it'll give you all the flags and tell you exactly how they work. See, it's not like Windows where you've got Windows and you've got boxes and drop-down lists and things. There's simple text commands for everything we do. But by having simple text commands, it means you can put them in Python scripts and automate things for yourself and make things easier for yourself. And if you want to remember the command, you simply copy it out of the putty window and paste it into a text file somewhere to remember how it works. Right, changing passwords. Remember the password command? You probably used it on Creative already. Well, if you're root or have root privileges, you can put a username after it, and you know when you forget your passwords, oh please Mark, you change my password. I've got my password, yeah? This is how we change it. I just put your username, so password idiot, yeah, we'll change idiot's password. Yeah? Yeah, password goldfish memory would change goldfish memory's password. Yeah? So you see how this works? This is the kind of what's going on behind the scenes when you've been working with Creative. You and I have been sort of hammering away on the keyboards doing all these sort of commands. By the end of this assignment, you will have enough knowledge to be able to effectively set up Creative yourself. That's what we're aiming for this. So every trick we've used with Creative, I'm going to show you in the next couple of weeks. So you'll be able to basically set up a server the same as Creative. Right, adding a user to a group. Okay, we create a new group, group add. Okay, that's an obvious one, isn't it? And then we use user mod, which means you're modifying the user account. The G flag means group. The A flag means add. So you add in to the group, new group, that username. Once you get your head around a lot of these commands, the rest of them become really easy because they all follow the same pattern. The trick is working out what the flags mean. And use the manual pages and it'll tell you what all the flags do. And you can check who's a member of the group by using the getEnt command. Okay, getEnt group, put the name of the group in there, developers, web users or so on. It'll list every member of that group, every person who's a member of that particular group. So you've got plenty of scope to check. Now, it is possible, this is the shell we're talking about, it's magic. The shell is magic because what you can do, when you're in the shell, you can switch to a different username. I can use the su command, switch user, and if I can log in as somebody else now. And it creates another shell over the top. And another shell over the top. I've been 7 or 8 shells deep on some projects. Then every time you type exit, you go back to the shell you were on before. Exit, back to the shell you were on before, so you can rewind your way through the system. But the sudo command is the most important command of all. You shouldn't log in as root unless you really have to, like the system's completely failed and you've got to get in there and sort of sift through the rubble and find out what's going on. Normally, once you've installed the system and you've created a user account for yourself, you shouldn't be logging in as root. So you should change the root password to something completely non-memorable, write it down somewhere and keep it safe, log out, and always from that point onwards, always log in as an ordinary user. As an ordinary user, there are special magic permissions, like Superman in the phone box. Yeah? You can transform from an ordinary user to a super user, yeah? With the sudo command. That is the phone box. Okay? So what we do, sudo command, you have to install it. There is sudo command, when you install it, it creates a special group called sudo. Now you know about groups. Anyone who's a member of the sudo group can switch to root privileges. Okay, so if you remember the sudo group, you can, at a flick of a command, you can become root without having to log in as root, without using the root password. And you can execute root commands. It means you log in as an ordinary user. Yeah, so you log in as Clark Kent, and then when you're in the middle of doing the work, can't access that command. In the phone box, sudo, yeah, you're out, and you're now a super user. So, all you have to do, if I want to add myself to the sudoers group, I type in add user, mtires, sudo. And I'm now a member of the sudo group. Now, be very careful, because anyone who's a member of this group can not only log in as sudo, but they can also create more sudo users. So it's not just a question of them doing bad things, but they can make other people sudo users. So it's equivalent of root, but it's a lot more secure. So let's see how this works. I'm going to run ifconfig. Now remember ifconfig from the lab yesterday? What does it do? What does ifconfig do? Not change the values. No. You find the IP address. That's it, network addresses. Remember, it gave that big list of all the IP addresses, various things. If I type it in as an ordinary user, it says command not found because the folder which contains that command, okay, is owned by root. And it's a member of the group root, which means ordinary mortals cannot. So when you log in as ordinary user, you can't even see the folder. So it says command not found. Now, so what I do is I put the word sudo in front of that command. And the first time you do it, you get this very important message. With great power comes great responsibility. You are now root for this command only. Technically, you could wipe the entire system. You could corrupt things, you could damage things. So think before you type. You can access any folder on the system. Okay, therefore that's about permissions. And it asks for my password again, my ordinary user password, to make sure I haven't left the computer and someone's come in my place. And now, bang, look at the bottom, there's my start of my ifconfig. So I should expect to see that if I have to type Raspberry for a password in any system, that will be a hanging offence. If you're in a job and you leave the password like that, that's a sacking offence. Okay? So you must make sure you change the root password once you've created the sudo user, but you also remember that, write the password down somewhere. If you want to execute lots of commands as sudo, you want to basically jump into a root shell for a while, you put the S flag in, sudo S, and that switches you to a different command prompt. Instead of a $, you get a hash sign, or the other way around. So your command prompt changes, and you're now logged in as root. And so when you finish work doing your sudo work, you type in exit, and you drop out of the root shell back to your shell. Then when you finish, you type exit again, it logs you out of the computer. Does that make sense? So exit takes you back a shell. Now, when you've entered the sudo password, you are sudo for 5 minutes. So you can enter multiple commands within that 5-minute window. You know when you buy stuff on the App Store? If you buy things within a certain time frame, you haven't got to keep putting your password in. Same idea. So if you don't issue a command for 5 minutes, it drops you back to normal user status. It's a safety feature. So if you're thinking about what you're doing, you come back and type it and it says enter your password, it just means 5 minutes has elapsed.